Been in electronics all my life. I was wiring 110 volt circuits when I was in first grade. That didn't stop from there. I've been ahead of the curve electronics wise from day one, so that's just something I just understand. I didn't have to learn it, it just came to me. And then I'd see that in the back of Popular Mechanics magazine and stuff. You said, build hovercraft, build in. I go, yeah, right. So one day when I was a little on the bored side, I just went in and did a search on the internet for anti-gravity to see what would pop up. And from the pictures, it looked like they were actually building something that worked. And then I checked out the NASA blueprints, and I went, okay, they're not fraudulent, I didn't mean blueprints, patent sheets. And when those aren't fraudulent patent sheets, there must be something to it. So I decided to build one and just followed the instructions on the website, and it worked. In fact, to do the whole lifter thing as a home hobby is very inexpensive. I mean, you'll have $1, maybe $2 in balsa wood, another $1 in super glue, and the aluminum foil you probably already have in your kitchen. The fine wire that you run across the top, you can yank out of an old battery clock from the dollar store. And right now it's just tied to this old NEC computer monitor, where I've disconnected the high voltage output, and I bring that up, which comes to the corona wire up here. I brought ground from the chassis, which comes down to the foil. When I turn it on, it will develop thrust through whatever means it does and lift. It should be all connected. I'm holding the corona wire of the way so it doesn't short against the foil on the way up. I'm going to hit the switch now. There we go. You see we're floating and there's nothing underneath and there's nothing above. I do have 3 threads coming off 3 of the legs that are tethering it down. I use very sophisticated little clothespins to hold my strings at whatever height I want the ship to float at. There's no balsa wood on the lower edge of the foil, it's left wide open. Of course the little corona wires rattle too, they're all vibrating. I've got small foam pads on the bottom of the sticks to act as shock absorbers, so when I turn it off, the sticks don't break, which they did. That's why the whole thing looks kind of out of shape and warped. It's had a long but rough life, but it's still a good flyer. To do lifter experiments right now, we need a high voltage DC source, but all CRT type displays, TV sets, computer monitors, they already have a high voltage power supply in them. In fact, this right here would be the guts out of a computer monitor. This yoke would normally fit over the back of the CRT tube. You need the yoke, it's part of the circuit, so you keep that. And here's the circuit board that's normally in there. Almost all of this has to do with video. We don't care about that. Just this section right here and the switching power supply on the input is all we care about. Because this high voltage wire here will produce the 20,000 plus volts that you need to make a lifter fly.